Hello, students, and hello to everyone. Okay, welcome back to your channel. Okay, so please don't forget to subscribe. Okay, yes, don't forget to hit that red subscribe button for more lesson contents for physical sciences and other science subjects. Okay, look, today we're going to be looking at momentum. Okay, some of momentum questions. Okay, this is a very important question that you have to know. It's going to come up during your exam. Any kind of a question that is going to appear like this. Okay, yes. So I'm not going to waste any time today. I'm going to be very quick as much as possible. So it says question 1. So the collisions happen in our country daily. So you know that collision cars like car accidents so on you experience daily, some news and so on. Okay, so in one of these collisions, a car of mass 1600 kgs traveling at a speed of 30 meters per second to the left, collides head on with a minibus of mass 3000 kgs traveling at the speed of 20 meters per second to the right. Okay, so this car is colliding with this minibus is colliding with this car. So yes, so let's say this is our car. The mass is equals to 1600. This is our minibus. Let's say this is the bus. The bus is equals to 3000 kg. Okay, so the two vehicles move together as a unit in a straight line after the collision. Please underline that, guys. Okay, so after the collision, they move together, meaning that they are combined objects. Okay, yes, meaning that their masses now are combined. They are one object, meaning that they are going to have or accumulate the same velocity. Okay, yes. So please note that down. Okay, so the very first question says calculate the velocity of the two vehicles after the collision. And mind you guys, you can see did some drawing for you. Okay, some little nice drawing. Okay, yes. So the question says calculate the velocity of the two vehicles after the collision. So let's calculate them after the collision. You know that the law of conservation of linear momentum states that let me just move it upwards. Okay, so you know that for our answers, let's just say answers, these are going to be answers. So this is going to be answer for number 1. Okay, let's just do answers that way. That side, there's some that says that we should do them that side. Okay, no problem, we can do them this side. Okay, so number 1.1 for the answers. Okay, 1.1 for the answers. You know that the law of conservation of momentum states that the linear momentum before is equals to the momentum before is equal to the sum of linear momentum before is equals to the sum of linear momentum after the collision. Okay, so this is the sum. Okay, this is your sigma. Okay, the sum of momentum before is equals to the sum, okay, of momentum after the collision. Okay, meaning that this is the momentum final, momentum initial of the two objects. Okay, so in doing so, we're going to have and say, meaning that we have the masses of the objects, mass of the bus, let's start with the bus, multiplied by the initial velocity of the bus plus the mass of the car multiplied by the initial velocity of the car. Yes, so this will be equals to their momentum, the sum of the momentum after, meaning that you have to add them. So mind you, after the collision, they combine together moving objects as a unit. Okay, they mean that they have one velocity, which is going to be one final velocity. So the mass of the bus plus the mass of the car, one objects, they have one velocity, which is the final velocity, right? Yes, so that's how it goes. So let's substitute right now. That's the mass of the bus. The mass of the bus is 3,000. Okay, 3,000 kgs multiplied by the initial velocity of the bus. The initial velocity of the bus is 20 meters per second, right? Plus the mass of the car. What's the mass of the car? 1,600 kgs. Multiplied by the initial velocity of the car. Okay, mind you guys, the initial velocity of the car is 30 meters per second to the left. Okay, mind you, to the left mean that you're opposing the motion. And mind you, please choose the right or left as negative or positive, but I chose my right to be positive and my left to be negative, so meaning that this is going to be minus 30. Okay, minus 30 is equals to, what's the mass of the bus? The mass of the bus is 3,000 kgs plus the mass of the car, which is 1,600 kgs. 600 kgs multiplied by the final. What's the final velocity? This is what we have to look for. Okay, the variable that we have to look for, final velocity. Okay, let's quickly punch that into our calculators. Please students, don't forget to punch that into our calculators. Okay, yes, and if ever I made some mistakes, I stand to be corrected, guys. Okay, 3,000 multiplied by 20 plus 1,600 multiplied by negative 30 is equals to 12,000. So this side we have 12,000. The sum of this side is 12,000. This side 3,000 plus 1,600. This is going to be 4,600, right? Very straightforward. VF, multiplying with that VF. Okay, so we're going to divide this side by 4,600 and this side by 4,600, so that you can conceive or receive our final velocity. So, and therefore our final velocity will be equal to what? Let's press the calculate. 12,000 divided by 4,600, that gives us 2,61. Please be careful with your round off. Okay, so 2,61 meters per second. This is our final velocity. This is our answer. Very correct. Everything is correct. Okay, I hope you saw that, guys. Okay, yes, if ever you have any kind of question, please, you can email me, you can comment, whatever the case may be. Okay, yes. Okay, so that's it, guys. There's something that came to my mind, that's something I should tell you. What I should tell you. Okay, yes, I think I told you everything. That when you have two moving objects, moving mean that just before the collision they were moving in opposite directions, means that the one car or one object is moving to the right and one car is moving to the left. You have to choose one which is going to move on the opposite side, okay, which is going to be negative. Okay, yes, but you know, left negative, right positive. Okay, yes, and after the collision they combined together and moved together, meaning that they were one object. So we have to add their masses. Okay, yes, mean that when they moving as a unit, they were moving at the same velocity. Okay, because they were combined. That's it. Very easy and straightforward. Okay, yes. Yes, so let's move to number 1.2. Let's move to 1.2. Let me just move to 1.2. Okay, let's say 1.2 here. Let's say like this. Okay, 1.2. 1.2 says, prove with calculations that the collision was elastic or inelastic. Okay, let me re-explain this, guys, because I know I explained this in previous videos of momentum as well as impulse. Okay, look, prove with calculations that the collision was elastic or inelastic. What does that mean when the collision is elastic or inelastic? Let's start with elastic, okay? When the collision is elastic, this basically means that the kinetic energy is conserved, okay? Meaning the kinetic energy before the sum of kinetic energy before the collision is equal to the sum of elastic collision after the collision. That's it, elastic collision, which is very rare to occur, like in real world situations. So, or inelastic collision. What does that mean? Inelastic collision means that the kinetic energy is not conserved. The sum of kinetic energy is not conserved, meaning that the kinetic energy before, the sum of kinetic energy before the collision, as well as the sum of kinetic energy after the collision are not equal, meaning that they are not conserved. That's it. That's a inelastic collision. And we can show these two different collisions by calculations, okay? Meaning that by proving calculations using the formula of the kinetic energy, okay? Yes, I think you still remember in grade 10, okay? Yes, so that's it. Yeah, that's straightforward. So you should know that in mostly we will receive inelastic collision, like in real scenarios, okay? Scenario like these, okay? Yes, and this is whereby maybe if ever it's an inelastic collision, this is whereby maybe the energy, the kinetic energy or the energy within the collision is transferred, okay? Yes, mean that when it's transferred, the energy is lost and is converted to become what? To become maybe heat energy, sound energy, and or even electrical energy, okay? Yes, so let's move to 1.2. Let's show calculations. Okay, so 1.2 we have to prove that okay, so I'm going to use the kinetic energy formula. So the sum, let's start with the sum of kinetic energy P4, so initial, so is equals to half what's the mass of the bus before there were separate objects, okay? So in the initial of the bus plus the mass of the car, this is squared, half mv squared, yes. So the initial velocity of the car squared, okay? So this will be equals to half, what's the mass of the bus, minibus is 3000. What's the initial velocity? Initial velocity is 20 meters per second plus what's the mass of the car, 1600. This is squared, so sorry. What's the initial velocity of the car? It's minus, it's moving to the left, minus 30 squared. Okay, so this will be equals to, would you mind please punch this on your calculators, guys? Oh, you didn't see that. Okay, would you mind please punch this on the calculators? So half, this is half, open bracket, 3000 close bracket, open bracket, 20 close bracket squared plus 1600 close bracket, open bracket, negative 30 squared, close bracket. That's it. So half 3000 20 squared plus 1600 minus 30 squared, half 3000 20 squared, okay, hope I did very well regarding the calculations. Half squared, okay. That give me let me recheck. That's it, Okay, that's it. That's the answer. The answer is 1. Okay, it's 1,320,000. Yes, 1,320,000. 1,320,000 joules. Okay, we're calculating the energy. This is the kinetic energy before the collision. Okay, so if this energy is going to be equal to the kinetic energy after, that is going to be elastic. But if this energy is going to be lesser, okay, because it has been transferred, okay, lesser than this energy or not equals to this energy, this basically means that the collision was inelastic. Okay, yes, so if ever it's also equals to this after, that was going to be elastic. Okay, let's calculate after. The kinetic energy after is equal to half the mass of the bus. Oh, right now the masses are combined, right? Yes, so the masses are combined. We're going to say half open brackets plus, we add the masses. Okay, the mass of the bus, the mass of the car, and the velocity is 1, meaning that the final velocity is the same, okay, of the two objects, because they are combined objects, okay, moving together. So in this case, other objects can move. Okay, I'll explain this later. Okay, explain this later. So this is going to be half the mass of the bus. What the mass of the bus is 3,000 plus mass of the car 1,600. What's the final velocity? The final velocity is it's 2,61, which makes sense, moving to the right. Okay, yes, 2,61. Let's just put bracket 2,61. This is equals to, press that in calculator, half 3,000 plus 1,600. This was supposed to be squared. Okay, squared. half mv squared. Okay, so the kinetic energy is half mv squared. Sorry about that, guys. So 1,600 multiplied by 2,61 squared. What's the answer? The answer is 15,667,83 joules. Okay, so it's 15,667,83 joules. I hope it gives you the very same thing, guys. That's how it goes. So that's it. That's the answer. Okay, so you can see the answer is not the same. The answer means that the sum of the kinetic energy before is not the same with the sum of kinetic energy after the collision, meaning that the collision is inelastic. Okay, meaning that the energy has been transferred, meaning that also has been converted to become some sort of heat, some sort of sound, and so meaning that when these two vehicles collided each other, the moment they collided, the sound was there, maybe the heat was released, and another kind of energies were transferred. Okay, yes, so the energy is lost there, and much energy was lost, meaning that there was very huge sound that resulted in that collision and other kinds of energies and guys. So and therefore so mind you, we have to prove the calculations. We proved the calculations that was elastic or inelastic, and therefore the collision. Okay, we have to say the collision. So and therefore the collision is inelastic, meaning that the kinetic energy initially, which is before, is not equal to the kinetic energy after the collision, and that's how it goes. That's it. Okay, that's it. Very correct and straightforward. Okay, guys, there's something that I wanted to tell you. See now, forgot everything now. Hey, but I think that is something that is very straightforward that you know, guys. You know, yes. So If ever you have any kind of calculation, any kind of questions, you can pose them into, or any kind of lesson topics that you want me to do on physical sciences, you can just comment. Okay, I'll just do them. I'll hear from you. This is your channel, guys. Feel free. Okay. Yes. Yeah. I'm just trying to think what I was going to tell you. Okay. This is what I was going to tell you. So look, most of you confuses this, okay, when we have to combine these objects. So this is after the collision. This basically means that the object after the collision, they cling together and they move together as one object. So that's why we have to add their masses, because they are one moving object, as well as they have only one velocity now, because they are one. Hope you understand that. Clear and very straightforward. But this can also happen before the collision, meaning that the objects were together, meaning that they were moving together, they were connected objects. But now, all of a sudden, after the collision, they separated. So, meaning that before the collision, we have to add their masses, and after the collision, we have to separate their masses, meaning that you have to say, for example, if this was like, you have to say their mass multiplied by the velocity plus mass multiplied by the velocity, final velocity, and. But before, the mass plus mass multiplied by the initial velocity. Okay, that's how it goes. Straightforward. Okay. Yes. Yeah. Please don't forget to subscribe, guys. See you in the next funny video. Cheers.